Hello, and welcome to my presentation of Tactical Hero Battle Game. This is a 2D strategy game inspired by titles like Battle Cats and Line Rangers, where players deploy heroes to defeat waves of enemies and protect their base. The motivation behind this project was to create a game that combines real-time strategy, resource management, and fun character variety. For a player's perspective, the goal is simple but exciting. Managing your energy resources wisely, deploying the right heroes at the right time, and crushing the enemy towers before they reach yours. I wanted to build a game that's not only fun to play but also encourages smart decision making and keeps players engaged across multiple levels. Here's a quick demonstration of my game. You start by selecting your characters, then you press start, and then you pick a level. For now, only level 1 is unlocked. So the buttons will be C, V, and B, and the goal is to destroy the enemy tower. For right now, I'll have to win. Give me a second. After you win, the details of the battle will be presented here, and you can see that 5 more characters are unlocked. Each one will be different because each character you get to unlock will be different. So now you can choose the other characters and you can go and play the next level. Now let's dive into the object-oriented design and design patterns I use in this project. At the core of the game is the unit class, which acts as a base class for all the characters, both heroes and enemies. This class defines shared attributes like health, speed, attack power, and position, as well as core behaviors like movement, attacking animation, and but from the base. But each of the classes here are different. For example, the green slime, blue slime, red slime, they all have different sizes, different speed. They don't be the same, but they're all inheriting from this mother class. The singleton pattern is applied in the resource class, since all game systems like this, like unit deployment cost checking and resource display, need to reference the same resource pool. I designed the resource class so that only one instance exists during the game. This ensures consistency and avoids bugs from conflict and duplicated resource states. The flyweight pattern was also incorporated so that the animations are only loaded once and shared across all unit instances. For example, if you were to call a centipede, it would be calling from the same place, so it wouldn't have to be loaded twice. And general OOP principles like encapsulation and modulation were found throughout the project, but with limited time I cannot show them all. With the limited time I have, I can't explain everything in detail, so I'll just explain the important ones. There's enemy logic for the enemy algorithms, resources for the what the player uses, game stats for visualizing data and getting it into a CSV file, units, which is the different types of units spawned in the game, tower, which is the goal of each game to destroy, and character selection, which is the preset before starting the game. There are other ones, but those were the main important ones. Let's take a closer look at the graphical user interface design. My main goal was to create a UI that is clear, easy to understand, and doesn't overwhelm the player, even as the game becomes more intense. The top section of the screen displays the game timer, 3 types of resources: solar, lunar, and eclipse energy. These are color-coded yellow, blue, and purple, so players can instantly recognize their current resource pool without needing to read small numbers. Below that, I showed the selected heroes with their color cost, coded by resource types. I added keybinds with C, V, and B next to each hero so players know exactly which button to press to deploy them. This small indication significantly improves stability and usability, especially during fast-paced battles. On character and level selection screens, I used large character portraits and level buttons for locked characters instead of removing them or replacing them with blank slots. Now on to the data part. This is the data I collected by auto-playing 50 times on each levels and playing myself. So to get the data and view it in a window, you start up the game and it will be an option on the top left. After clicking on that, there will be a window that pops up. This will display the win-loss ratio from each of the levels, level 1, level 2, and all levels combined. For unit analysis, it will show total units deployed average damage dealt by units, win rate by units. For resource analysis, it will show the usage of each resource. So like for example, level 1, where Eclipse is non-existent, only Solar and Luna will be used. And for performance, there'll be total damage versus duration per run, and a correlation heat map for duration, total damage, and win. For more in-depth, you can just read them one at a time and slowly analyze which are most effective and which are not effective. For extra features, I implemented a flexible level unlock system, a gray out system, a simple exit system, and a character selection system. This was Ricardo Marimonato, student ID 66105455502. Thank you for listening.